Grace Under Fire, an in-depth guide to the Jaguar XK8, X100, and its battle with corrosion introduction. The allure and the Achilles heel launched at the 1996 Geneva Motor Show. The Jaguar XK8, codenamed X100, was a pivotal model for the Coventry-based manufacturer. As the successor to the long-serving XJS, the XK8, designed by the celebrated Jeff Lawson, represented a new era for Jaguar under Ford's ownership. With its graceful lines consciously echoing the iconic E-Type, a newly developed AJ V8 engine, and a blend of performance and luxury, the car was an immediate critical and commercial success. It was, by all accounts, one of the most beautiful cars of its time. However, beneath this stunning exterior lies the model's most significant and well-documented vulnerability, a profound susceptibility to corrosion. For prospective owners and enthusiasts, the XK8 presents a paradox. A car that can look immaculate from a few feet away may be hiding advanced structural decay that renders it beyond economic salvation. This is not an occasional fault but a systemic characteristic rooted in specific design and manufacturing choices of the period. This report will provide an exhaustive, technical analysis of the Jaguar XK8's corrosion hotspots, the underlying causes, and the methods for inspection, rectification, and prevention. For the informed buyer, rust is not a reason to dismiss this magnificent grand tourer, but a challenge to be understood and managed with diligence and respect. Part 1, The Anatomy of Corrosion, Key Hotspots and Their Causes. The corrosion issues affecting the X100 platform are not random. They are predictable and occur in specific locations for specific reasons. Understanding these mechanisms is the first step toward a successful ownership experience. 1.1 The infamous floor pans. A legacy of the production line. The single most notorious corrosion point on the XK8 is the front floor pans. This issue is widely documented by specialists and owners and is particularly deceptive because the rust propagates from the outside in. A dry interior carpet, therefore, offers no guarantee of a solid floor beneath. The problem originates from a manufacturing process. During assembly, a thick steel strengthening plate was welded to the underside of each front footwell. These plates, complete with rubber bungs and welded nuts, served as jigging points to mount and move the body shell along the production line. This design created a permanent, unsealed cavity between the jigging plate and the thinner steel of the floor pan. In service, this cavity becomes a perfect trap for water, road salt, and debris. With no drainage, the trapped moisture relentlessly attacks the metal. The thinner floor pan steel corrodes first, often leading to significant perforation before any symptoms are noticed inside the car. Owners typically discover the problem only when they find damp or soaked carpets, a definitive sign that the floor has already been breached. What may appear as minor bubbling on the underside can conceal holes large enough to fit a fist through once the carpets are lifted. This corrosion can also spread rearward along the transmission tunnel. While some evidence suggests this specific jigging plate design was removed on the later 4.2-liter models, post-2003, a thorough inspection of this area is considered mandatory for all X100 variants. This particular flaw is not a typical design compromise related to aesthetics or vehicle dynamics, but rather a direct consequence of a manufacturing methodology. It is a scar left by the assembly line, where the efficiency of production was prioritized over the long-term durability of a non-visible component. This decision, likely influenced by Ford's efficiency-driven management, created a perfect, undrained moisture trap that would inevitably fail over time. It offers a window into the manufacturing philosophy of the era, a blend of modern production techniques with a lingering lack of foresight regarding corrosion prevention in hidden areas. 1.2 Sills and rocker panels. The debris trap corrosion of the sills, or rocker panels, is another extremely common failure point, especially affecting the rear half of the sill where it meets the rear wheel arch. Like the floor pans, this area can appear sound externally until the rust perforates the factory stone chip coating. The primary cause is a design flaw in the rear sill lip, which effectively forms a shelf that collects and retains road grime, mud, and moisture. This damp poultice is held directly against the steel, creating ideal conditions for rust to form. The corrosion then spreads into the main structural box section of the sill and migrates up into the rear quarter panel and wheel arch. This area is also a common site for poor previous repairs, often hidden with excessive body filler. The progression typically begins on the outer lip and around the jacking points. If left unaddressed, the decay will compromise the inner sill structure, turning what could have been a small patch repair into a complex and expensive fabrication job involving multiple panels. The presence of any visible rust on the outer sill is a strong indication that the inner panels are also compromised. This represents a classic compounding failure. An initial design flaw, the debris-trapping sill lip, is exacerbated by a secondary factor. The very stone chip coating intended to protect the area instead conceals the early stages of corrosion from the owner's view. By the time the damage becomes visible as bubbling paint or a soft spot, the rust has often progressed from a surface issue to a full perforation affecting multiple layers of steel. 1.3 wheel arches. Beyond the plastic liner, both front and rear wheel arches are vulnerable, but the rear arches are particularly notorious for severe corrosion. The plastic wheel arch liners, fitted to protect the arches from stone chips, ironically contribute to their demise. Over time, they trap damp dirt, salt, and mud against the metal bodywork, creating a hidden environment where rust can flourish undetected. The rear liner is especially problematic as it covers a horizontal shelf that is a prime location for rot to set in. One of the most insidious rust traps on the entire car is found in the rear wing, just above the bumper. A mud trap forms in the cavity around the boot vent, causing the panel to rot completely from the inside out. When inspecting, if the outer arch shows any sign of corrosion, it is almost certain that the inner arch panel has also rusted through and will require complete fabrication to repair. This is a perfect illustration of the illusion of protection. A component designed to shield the bodywork from damage becomes a key enabler of the very corrosion it is meant to prevent. The liners are not hermetically sealed, allowing fine particulates and moisture to creep behind them over years of use. This hidden poultice is shielded from car washes and prevents the area from drying out effectively, dramatically accelerating the corrosion process. This underscores the critical importance of a maintenance schedule that includes the periodic removal of these liners for thorough cleaning and inspection. 1.4 The structural core. Chassis and subframe corrosion. The most serious and potentially life-threatening rust on an XK8 affects its primary structure. While less common than the more visible panel rust, corrosion in these areas directly compromises the vehicle's structural integrity and safety, and is often the reason a car is deemed beyond economic repair. Key structural hotspots include front crossmember, located directly under the radiator. This large structural member is heavily exposed to road spray. It is frequently found to be severely corroded, especially near the towing eye, once the engine undertray is removed. Front chassis legs. A critical hidden rust area is the main front chassis rail, located behind the front subframe and inner wing. This area is very difficult to inspect and repair, often requiring the entire front subframe to be removed for proper access. Rear chassis legs, visible just behind the rear wheels. This is another crucial structural point. The corrosion here is caused by a design that uses several layers of overlapping steel. These layers were not seam sealed at the factory, allowing water to wick between the panels via capillary action and cause the structure to rust from the inside out. Rear subframe mounts. The heavy-duty brackets that attach the rear subframe to the unibody can trap moisture against the sills and floor. This leads to severe, concentrated rust at a critical suspension mounting point. Probing this area with a tool can often reveal complete perforation. Seat belt anchors. As a direct consequence of advanced corrosion in the sills and floor pans, the seat belt anchorage points can become compromised, leading to an immediate roadworthiness failure. These structural rust points reveal the Achilles heel of the XK8's unibody design. The vehicle's strength relies on the integrity of all its stamped steel panels working in unison. The corrosion hotspots are consistently located at the most critical junctions where structural loads are transferred, such as subframe and suspension mounts. It is at these exact points that the manufacturing process involved overlapping steel panels without adequate seam sealing. This created built-in water traps at the most structurally significant locations, meaning the car's fundamental safety is threatened by a flaw in its assembly. This elevates the pre-purchase inspection from important to absolutely critical. 1.5 Secondary corrosion points. A comprehensive checklist beyond the major areas of concern. Several other locations require careful inspection to form a complete picture of a car's condition. A-pillars. Rust can form at the base of the A-pillars, often linked to blocked sunroof drains or a failing windscreen seal, which can in turn cause water leaks into the cabin. Windscreen base, scuttle. Drain holes in the scuttle panel below the windscreen can become blocked with leaves and debris, causing water to pool and rust to form under the plastic trim. Boot floor and battery tray. The boot floor, particularly the area where the battery tray is welded to the floor, is a known weak spot. The entire area should be inspected by lifting the boot liner and sound deadening material. Rear bumper mounts. The metal guides to which the rear bumper is attached are prone to rusting away. Any movement or wobbling of the rear bumper is a key indicator of this problem. Doors. While less common, rust can appear along the bottom seams of the doors or is evidence of a poor quality previous damage repair. Part 2. The pre-purchase inspection. A forensic approach. A thorough, forensic inspection is the only way to accurately assess the condition of an XK8 and avoid acquiring a vehicle with ruinous hidden problems. 2.1 Beyond the shine. Detecting hidden rust and poor repairs. A key takeaway from owner experiences is that a visually stunning XK8 can be structurally rotten. A skeptical and methodical approach is required. A potential buyer should arrive at a viewing equipped with a bright torch, a small magnet to detect non-metallic body filler, and a blunt probing tool, such as a screwdriver handle, to be used with care and the owner's permission. Attention should be paid to visual cues that indicate previous repairs. These include uneven panel gaps, overspray on trim, and mismatched paint texture. The lower sills have a specific factory stone chip finish that is difficult to replicate perfectly. Any deviation here warrants suspicion. Look for unusual lines in the under seal, which can indicate a patch repair has been blended in. The use of body filler, and in some cases even aluminum tape, to cover corrosion is a common bodge found on these cars. 2.2 Essential checks. What to do on a viewing. Certain checks are non-negotiable during a pre-purchase inspection. The interior check. The buyer must insist on lifting the front carpets, felts, and underlay completely. Any sign of dampness, water staining, or a musty, mildew smell is a primary indicator of advanced floor pan corrosion. The boot check. Similarly, the boot floor carpet, spare wheel cover, and all sound deadening material must be lifted to allow a clear inspection of the boot floor pan and the area around the battery tray weld. The ramp inspection. It is impossible to properly assess an XK8 structural condition without access to a vehicle lift or ramp. This is the only way to gain the necessary access to inspect the floors, sills, chassis legs, crossmember, and subframe mounts thoroughly. Probing and poking. With the car elevated, the hotspots identified in Table 1 should be systematically checked. Gently push and pull the rear bumper. Any significant movement suggests its mounts have rusted through. If the seller permits, removing the plastic wheel arch liners will provide a much clearer view of the condition of the arches and sills. Part 3. Rectification and restoration. The path to salvation. Should corrosion be found, there is a well-established path to correct and lasting repair. Cutting corners is a false economy that will only lead to the rust returning. 3. 1. The right way to repair. Cutting out the cancer. The foundational principle of rust repair is that all corroded metal must be aggressively cut out until only clean, bright, solid steel remains. Simply treating the surface or welding a patch over existing rust is a temporary fix that traps the corrosion, guaranteeing its return. Once the compromised metal is removed, the surrounding area must be ground back to bare metal. This clean metal should then be treated with a high-quality rust inhibitor or converter, such as a zinc phosphate primer or a product like POR 15, to passivate the surface and prevent flash rusting before new metal is welded in. 3.2 Panel perfect. Fabrication versus aftermarket panels. Fortunately for restorers, the market has responded to the XK8's common issues. Whereas previously all repairs required custom fabrication, high-quality aftermarket repair panels are now available for many of the most common rust areas, making restoration more accessible and cost-effective. Available panels. Specialist suppliers offer press-formed repair panels for the front floor pans, left and right hand, the rear half of the sills, and the rear wheel arches. Fabrication. For areas where repair panels are not available, such as the chassis legs or inner wheel arches, or for damage that extends beyond the scope of a repair panel, skilled metal fabrication is required. This involves creating new sections from fresh sheet steel, typically 1.0 mm to 1.2 mm thick, and carefully shaping them to replicate the original factory contours. 3.3 The finishing touches. Sealing and protecting the repair. The longevity of a repair depends entirely on how it is finished and protected. Welding. Modern MIG or TIG welding techniques are essential. To prevent the new seam from rusting from the inside, a weld-through primer should be applied to all mating surfaces before they are joined. Sealing. This is a critical step that was often inadequately performed at the factory. After welding and priming, all new seams and joints must be sealed with a high-quality polyurethane seam sealer, e.g., Tiger Seal, to create a waterproof barrier. Protection. Finally, the repaired area should be coated on the underside with a durable, flexible stone chip protector, which can then be painted in the body color or a suitable satin black finish to replicate the factory look. Part 4. Proactive preservation, ensuring a long future for both new and existing owners. Proactive preservation is the key to halting corrosion in its tracks and ensuring the car's long-term survival. 4.1 The shield below. The critical role of undersealing and cavity waxing. The single most effective measure an owner can take is to have the vehicle professionally rust-proofed. This is not a simple task and, if performed correctly, is a multi-day process. Simply spraying a single product over a dirty underside can trap moisture and accelerate corrosion. A thorough, professional treatment is a multi-stage system. The entire underbody, wheel arches, and suspension components are meticulously steam cleaned or pressure washed to remove all dirt, grease, and loose rust. Any existing surface rust is mechanically removed or treated with a chemical rust converter, e.g., Bilthamber Hydrate 80, Fe 123, to neutralize it. A durable, abrasion-resistant underbody sealant, e.g., Dinitrol 447, is applied to all exposed surfaces. A non-hardening, creeping cavity wax with moisture-displacing properties, e.g., Dinitrol, wax oil, Rustbuster mil-spec, is injected into all internal chassis sections, sills, crossmembers, door bottoms, and other enclosed cavities. This requires specialized high-pressure equipment with long, flexible wands capable of providing 360-degree spray coverage inside the cavities. This distinction is critical. An owner's mindset must shift from getting the car wax-oiled to having a complete, multi-stage rust-proofing treatment performed. The latter involves a comprehensive system of preparation and the application of two different types of products, a durable surface coating and a penetrating cavity wax, to protect the car both inside and out. This represents a significant difference in both cost and long-term effectiveness. 4.2 The ownership regimen. Cleaning and care beyond initial treatments. A consistent maintenance regimen is vital. Regular and thorough cleaning, particularly for cars used during winter months in regions where road salt is prevalent, is essential. This must include pressure washing the underbody and inside the wheel arches to remove corrosive salt deposits. Drain holes at the base of the windscreen and in the boot area should be checked and cleared of leaves and debris regularly to prevent water from pooling. Finally, a brief annual inspection on a ramp is a wise investment, even for a rust-proofed car, to identify and touch up any chips or breaches in the protective coatings before they can develop into a more serious problem. Part 5. A question of class. The XK8 versus its contemporaries. To fully understand the XK8's corrosion profile, it is essential to place it in the context of its main rivals from the same era. A potential buyer cross-shopping these Grand Tourers will find that each marque presents a different set of challenges. This comparative analysis reveals that a buyer in this market is not simply choosing a rust-free car over a rusty one, but rather selecting which type of corrosion risk they are most comfortable managing. The Jaguar XK8 presents the risk of widespread, but well understood and repairable, body and chassis corrosion. With good aftermarket panel support, the path to rectification is clear, if potentially extensive. The Mercedes-Benz R129 SL offers a different proposition. Its body is generally perceived as being built to a higher standard, often described as being like a bank vault. However, it harbors a hidden killer in its rear subframe assembly, which can corrode to a dangerous degree while being completely hidden from view, affecting even low-mileage, cherished examples. The BMW E31 series is a testament to 1990s German engineering and feels more solidly constructed than the Jaguar. It is not, however, infallible. It suffers from very specific and well-documented rust traps, such as the sunroof panel and battery box, that require targeted inspection. The structural corrosion is generally far less pervasive than on the XK8. Conclusion: a worthy investment. The Jaguar XK8's susceptibility to rust is a significant and undeniable aspect of its character, baked into the car's design and manufacture from the very beginning. A neglected example that has been exposed to harsh climates can quickly become a financial catastrophe, with repair costs far exceeding the vehicle's value. However, these issues are a known quantity. A robust and knowledgeable global community of owners and specialists has spent decades documenting these flaws and developing effective strategies for repair and prevention. The aftermarket has responded with the production of high-quality, affordable repair panels for the most common problem areas, making restoration a more viable prospect than ever before. Ultimately, the XK8's fate is in the hands of its custodians. A rusty example should be approached with extreme caution, but a well-maintained car, or one that has been properly restored and is diligently protected, represents one of the most compelling value propositions in the modern classic Grand Tourer market. The key to a rewarding ownership experience is not fear, but knowledge and diligence. For the prepared enthusiast, the battle with corrosion is not a deterrent, but simply part of the car's story, and overcoming it is part of the deep satisfaction that comes from preserving such a timeless piece of automotive design.